Hello guys, in this video I'll try to show you a recipe or a common standardized strategy I created to solve recursive problem based on some of the problem I solved previously. So this is the recipe you can see on your left side of the screen. So basically this is the recipe to solve the backtracking problem. So you can treat this like a blueprint and you have to fill this out according to the problem. So let's do a problem, that way you will understand what it is. So let's take a problem from this subset problems. So basically what it is you've been given an array and you have to find all the subsets for this array. So basically these are the subsets. Empty set 1, 1, 2, 1, 2, 3, 1, 3, 2, 2, 3 and 3. These are the subsets. So these we have to find. Okay. So in order to find the subset, let's start with the empty subset, because empty subset is a subset of every array, of every set. So let me create this empty subset. Now what we can do is we can add each element to this subset one by one. So we'll loop. So we'll loop through all the elements from start to the end from this array. Okay. So let's do this. So let me create three branches because of three elements. So we added 1, we added 2, and we added 3. So this would be the result. Like this, we will include this also in the result. This empty subset and 1, 2, 3. These are the four subset, and this 4 will be in the result. Okay. So what we understood from this is every node will be a subset, and we want all the subset. So here we write the condition. We Here we write the condition which will represent like when we will add the subset to the result. But for this case, every subset we have to add in the result, so we don't need the condition here because we are adding every subset to the result. Okay, so this part is done. Now make node array. So what does that mean is how we are making a node. So these three are the node uh, in the tree. So how we are making this is we are iterating over all the elements of this array and adding each element to this to the parent. Okay, so uh, how we are making it by add for loop and add each element I in the array. Okay, so how we are adding is, so this is the path is basically the parent subset, which in this case is empty set. So path, we will add each element from I to this path. Okay, so let's do this path dot append num5. Okay, so we came from here to here, we added 1. Now to add 2, we again go back to the empty set, and then we'll add 2 again. So first we'll go back, then we'll come back to 2. So we are at 1. Now from 1 we'll go again to the empty set, and then we'll add 2. Okay, so going back will be our backtrack logics. So this would be our backtrack logic going back. Okay, so let's go back. So again by popping 1, we are again back to the empty set. Okay, so this was our backtrack logic. Now again in the next loop I will increment to 2. The I will be here, and now we again will add 2. Okay, and then we'll go back to empty set, then again I will come here and we will add 3, and then we'll go back. Okay, so this part is done. Now only last part is remaining, which is the backtrack, call the backtrack. So what does that mean is, so this is our tree. Now in order to move this tree further, what we need to call is we need to add the recursion, which will create a child tree after 1. Okay, In order to call recursion, we have to call the same method again. Basically, this is what recursion is. So we want to do recursion. Okay, so let's do recursion. So when we could have done recursion, we could have called backtrack after pop or before append. Why we are calling it in between? So this is how the flow is. So first we are added one. We called the recursion. This is the recursion we've called after adding one. Then we went back. Now we added two. We called the recursion. We went back. We added three. We called the recursion. We went back. So that is the flow. Okay, basically, so this is the flow. This video can be long because I'll explain everything, what am I doing, why am I doing all this. Okay, so okay, let's call the same method again. Now what would be the starting position? Start position. Okay, so path will be same. In recovery we want the path to be the parent subset. From parent, in this case it would be 1. So we appended 1 and it would be, now from here we will create the child. So path will be same. Now from where should we start? So if you see in the above tree, we started from I0. Okay, this is 1, this is 2. These are the indices. So we started with index 0. Okay. So if we do this again and we put here start, again start, and start is what it is 0 basically, because we are starting from 0. So it is from 0 till the length of the array. Okay, so if we put 0 again in backtrack, so how, what we are doing in backtrack method, basically we are for looping in all the elements of this array and adding it one by one by popping it and then adding second, then popping and then second, adding second. Okay, so this is what we are doing in backtrack method. So if I call backtrack with start equals to start, which is 0, so it will then add all the elements one by one, the same way we did above. So in 1, which is our parents subset, which is path, and it will add each element one by one in the path. So it would be 1 1 1 2 1 3, similar, same like how we added 1 2 3 one by one here. So this would be our subtree. But is this correct? Is this correct? So we are getting 1 1. Is 1 1 our subset? Nope, it isn't. And we are getting 1 2 and 1 3, but 1 2 and 1 3 is the part of subset uh, result. So we don't want this, but we want this and this. So what is 2? 2 is the second element. So 1 was 0, I equals to 0, and 2 is I equals to 1. So basically we don't want 1 same element, but we want second element. Now you would say start plus 1. No, so start plus 1 is not the thing, because start is always 0, and again for this it can work, because start is 0 and 0 plus 1 is 1, so you will add 2 and 3. But when we will call start here, because in the first backtrack call only, in the second for loop, the start will be same, it would be 0 again. So again what we will be adding is 2 comma 2 and 2 comma 3, if we use start plus 1. So again 2 is not the answer, and 2 3 is a part of answer. So we basically, what we want is second element from the current element in the answer. We don't want the same element, so we cannot put we cannot put start. I told you why. So what we want is I plus 1, basically the second element. So if we are calling for 1, we want to add till start from 2 2 3, and if we are at 2, we want to start from 3, next element. So we'll add 3, and 3 there is no next element, so there will be no recursive call. Okay, So you understand the reasoning behind what we have to pass in backtrack. So okay, so let's pass I plus 1 in the backtrack. Okay, so what will happen now? So I plus 1, so it will start from the next element, so it will add 2 and it will add 3. After 3 there is no element, so this will not happen. For 2 it will start from the next element, which is 3, so it will add 3. There is no next element there, so there will be only one child. And 3 there is no element, so that would be a recursive tree. And we are adding each subset to the result, so this would be our result. This all subsets will be the part of the result. Now again for this will call backtrack, but 2 was the element, so we'll start from again from the next element. So we'll add next element, which is 3, and for this 1, 3 and 4 is not there, so that's it. So basically recursion, so this will not happen. So again this will be added to the answer. So this would be our result, same as like this. And let's fix the argument. So backtrack is taking 2 argument, which is start would be 0 as I told you, and path will be empty. So we are starting from empty, so path will be empty, and this would be our this would be the answer. That's it. So let me show you. See this? Backtrack, start path, result append this, path append num I plus 1, path pop, result 0 this, and if I run this answer accepted, and you got your answer. So now we'll tackle this next problem with the same with this same blueprint. We'll tackle another problem. So it's already 11 minutes video, so I'll create a next video part 2 where we'll tackle next problem with this same blueprint. So see you in the next video.